Hey guys, we're Team Mewt. Our whole idea was to build a musician's toolbox for practicing new music. Like Sid mentioned, I'm Vedant, this is Masaki, and this is Ali. Before we go into what Mewt is and why we went about all of this, I just want to go through my process for learning and practicing a new song. So, step one for me is solo the drums for any tricky sections that I can't really figure out. Slow it down to identify what exactly is being played. Practice, practice, practice. And once I'm comfortable with improvising over what's being played, I want to remove the drums and just do my own thing. And of course, as a drummer, metronome, metronome, metronome. I always want that click track. Now, here are the problem statements that we're trying to address. We want to be able to solo and mute specific instruments, slowing down or speeding up the entire track, and of course, creating a metronome that follows the track perfectly. Not all songs have a perfect tempo, not all are recorded to a metronome. So if I have a song that's actually at 143.25, setting a metronome at 143 BPM will eventually lead to it diverging over the course of the entire song. Our goal was to create a metronome that follows it perfectly. Why does it matter? Like I mentioned, to help people like me who are learning, and of course professionals, play along with their favorite songs, either just for practice or even live. Let's see Mewt in action. Actually, let me give you a quick demo. You cashed in on my promises. You know I'm too generous. Never help you, 'cause I'm done cleaning up your mess. Found myself in my regrets. I've become a little stronger now. So as you guys could see, we had a little link where you could paste a Dropbox where you could paste a YouTube link. We would then download that. We also allowed you to enter a speed, like a float value, which let you speed up or slow down the song. In the case of the demo, we'd slowed it down to 80%. Another thing that you did see was this is a very DAW-like functionality that we wanted in there. So the ability to mute, solo, and adjust relative levels. So you can make your own mix that you want to play to. Additionally, all the lines that you saw there were the beats that we detected. I don't know if you guys noticed it, but when it sped up, we actually had the beats speed up along with that. So we had a metronome that followed the song. We also added in a little functionality that when, in case the model detected a beat at the wrong place, we'd allow you to actually click on it and move it around and make it like fix the metronome. Okay, so how it works. Step one, the user pastes a YouTube link into our UI. The server then downloads this audio and processes it, whether it's time stretching or beat tracking. We also did want to include pitch shifting for you vocalists out there. Unfortunately, with the 24 hours or so that we had with the hackathon, that wasn't feasible. Future work. Step three, the server then runs stem separation through. We were using a model called Dmux, which I think has been addressed today a couple of times. Step four is the actual UI that you guys saw, where the user can play around with the tracks as they want, mute and unmute the stems, and play them with a metronome. Key features, like I mentioned, source separation using Dmux, time stretching and pitch shifting for practicing at different speeds, mute and unmute stems for focus practice, downbeat detection to create a metronome that follows the song, and this ideally would be all web-based, so you don't need to install anything. You just paste your YouTube link and go. Thank you. We've been Team Mewt. You can reach out to us for any questions, or if you guys want to try it out on our Discord or Instagrams. Thanks.
Thank you everyone for staying till the very end for listening to the Hack Day talks. We are Contrapunks, and I'm Vibhav. This is Abhinav. We created a tool called the Contrapunk, which is a real-time accompaniment generator. So it's based on counterpoints in Western classical music. The reason it's called Contrapunk is because Contrapuntal writing in classical music uh, just sounds way better than like counterpoint and sounds a little fancier. So you took like contrapuntal and just made a name out of it. And I'm gonna call Abhinav here to explain what counterpoint is.
Hi everyone. So, counterpoint is a Western classical music theory concept, wherein if you given a melody line, we try to generate two or three like or multiple melody lines based on the original melody line, and it follows a set of rules which are already there, like by analyzing pieces of Bach, Mozart, all these guys, and it's based on like consonances and dissonances. So we try to, as part of our code that we implemented in Python, we've tried to implement these rules in our algorithm, wherein we leave out the dissonances such as seconds and the sevenths as the suggested notes, and we've tried to create the secondary melodies motion as like as far as possible to move in a stepwise motion, and to avoid parallel fifths and octaves because they just sound like the melody itself. So we've tried to harmonize the melody uh, while the secondary melody sounds an independent melody on its own. So there are like several types of counterpoint species. We've tried to do like the first species, just the first species, wherein the like one note is mapped to the one note on the generated melody, and the second species and the third and fourth species, they all have like multiple notes being generated on the uh, map to the like the original melody. And yeah, I'll invite Vibhav to discuss the features of what our algorithm does. And
So we made like a simple Python script which acts as a standalone application. It will basically take in your MIDI input and then split it and output to multiple buses. So you have to define these buses from like beforehand into Mac. So this right now it only supports Mac. So these are IAC buses, inter-application communication buses. And what we do is before these are sent to the buses, we pre-process these MIDI inputs to change the notes of those MIDI messages. So we basically take the list of possible notes that we can input and then score these notes, which would be the best possible note that we can put in next. And then we use like a random function to pick out the random note from there. And then also record these previous inputs so that next time we are generating an output for the next note, so we know what came before and then give a better output. So the support in pre-processing modes is basically how we went about making this tool. So first we did like diatonic intervals, so we did thirds, so that every time, so if you have 4 outputs, every time you press a key, you get like a seventh chord. Then we did it for diatonic with random, and then we added some contrary motion. So we gave like more score to notes that went in the opposite direction. And then finally we added like one more rule. I don't remember now what it was exactly, but which let us know that okay, we've like kind of finished all the standard counterpoint rules. Then these are the current features that we support. So I'd like to go ahead and show the demo for this. Yeah, so here we have, one second. So here we have the UI for Contrapunk, and it was made in TK Enter in Python. You can see that we have the MIDI input for it, and I've selected 4 outputs, and then I'm selecting the ISC buses that I've defined, like I've added in Mac. And then you can see the key that I want my diatonic notes to be generated in. And then I'm saying add strict. So there are different modes, and I'm saying that I want strict counterpoint rules. Then I press the start button. I usually forget to do that. And then here Abhinav is playing just random melodies. So here you saw that these, one second. So here you saw that these melodies were generated, right? So the first instrument that is there, so it's taking the input directly from the MIDI input and then copy pasting it. But the outputs the inputs into the instrument 2, 3, and 4, they are generated based on counterpoint. So 2 is a counterpoint generation of 1, then 3 is of 2, and 4 is of 3. So that way, like we thought like it would be a good idea to do that. So we kind of create like a very good sounding like harmony together. So it, you can also call it a chord generation at this point, because that's how it acts. So the next we are planning on supporting global tempo. So there will be some sort of click track and you can play to it, and the harmonies that are generated or the counterpoints that are generated are kind of have like a life of its own, and it would sound like different people who are like playing those tracks. And then these are some other supports as well. And if you'd like to see something in this tool, please reach out to us. This is our contact information. Thank you so much.
Good evening, all. We're very happy to again be here and give our talk on the yesterday's presentation in a very glimpse manner. And we have our team of my Balamurugan and Hrithik and Guru. So immediately I jump into the presentation. So what are the problems in hand? The problem statements were given by Indian Music Heritage Museum, and then we have taken out of the 12, we have taken addressed 4 use cases in that, and then it has been clubbed up over here. One is the understanding the pattern formation using the ragas, then identifying the fundamental pitch and the accuracy of the sword note detection, then exactly identifying the 12 swaras and also the 16 swara system. Apart from that, we also try to implement the 22 swara system also. Then finally finding out if a music is a tune is played with a raga, then we have to find out the rasa out of that, out of the navarasas. So all these things are gamified, and then we have presented a small game for that. The mainly the what is the why we need be such a kind of a game, because everyone it is very you all know that we are it's very restricted to only a few people. Classical music, of course, all over the world classical music is only restricted to few, and then because of the it's of the complex nature that is present over there, so we have to attract more people. That's what we when we spoke with the director, she told we need attract more people, and it should be more enjoyable and trending, and there should people retracting from the study case should be high. The retention rate should be good. That is what they told. So for that case, we have designed this game, and you can see there is first one is the Shruti system, and the Alangar, then the Swara detection will come. How we are doing, the first we are going to find out the 12 swaras, the sarigama pada nisa, that one has to be detected with proper sa re 1 re 2 ga 1 ga 2 ma 1 ma 2 pa da 1 da 2 ni 1 ni 2 sa. This all these things should be placed as boxes, and then when they get the swara over there to the ears, then they should be able to click whether which swara they are hearing, and then they have to click the button. Like that it starts. So that is basically, then slowly the patterns will be formed and the ragas will be formed next. Then the patterns will they have to form, and then they have to develop it. That you will see the demos over here now.
So basically, in order to, as we seen from the previous task, we couldn't have a standard electronic sitar or standard electronic classical instruments. So we took the basic pitch, like C pitch of a sitar instrument, and we generated the 12 semitones for us to implement these things. So for the overall UI, a player can free practice and get the gist of the notes that they are being played, and so the player is being rewarded based on that. And for level 2, we hide the visual cues that are being given in order to focus only on the auditory. And based on the levels, the complication also increases. And you can compose your own pitches, like in the end of the video, as you see, in order to develop your own patterns.
Yeah, here it is about the sore note detection or anya swara detection. If there is one raga, there is there are some ragas where there are upanga ragas and bashanga ragas where there the anya swaras are possible. Like that, that's a sore note actually. Where when there's a pattern and then if there's a pattern is played, if you're able to hear to that, and then if there is going to be a glitch over there, you have to identify and say where that has occurred. That one also, we for the practice purpose we are giving it over there. Simply we are taking for the simple C major Shankarabharanam we have taken as a twinkle twinkle, and the first phrase is given over here.
So what you saw is that the just a demo of detecting the off note. The person is used to hearing the normal and accurate melody, and when an off note is being pronounced, the player should be able to detect it, and the score should be rewarded based on that.
Okay, then the entire the system of 12 pitch system, which we see in the Western side, but it is our classical music is not based on the 12 pitch system alone, and it is totally based on the 22 based system, and the entire Melakarta scheme and the parental and Janya scheme is all based on that. So we have to train the students based on the 22 Shruti system with the Gamakas over there. For that, they have made this kind of a microtonal analysis also for the pattern recognition. Then comes the rasa identification. Out of the nava rasas, we have to identify, because the final element of music is emotion identification. So for what kind of ragas, there are classifications of ragas based on this too. When a phrase is heard, and such kind of a phrase, what kind of an emotion that is evokes over to you, that also the student can get learned out of the ragas. Initially, it will be given through very simple patterns. Then a complex, a single raga with a different kind of several different bhavas also can be given over there. You can hear to the. So.
So as you can see, when the player click the Shanta as an emotion, Shanta is basically peace and happiness. So when you hear the emotion provoke this happiness, and when you click that and get it right, you would be rewarded based on that.
So it is it's a very basic thing. The raga in which the Harivarasanam, the song which was played over there, is in the raga Mattimavadi, and Mattimavadi is typically it is patterned to the rasa of Shanta there. So this one we have to. These are highly psychoacoustics, as I told. It is depend upon the person. Ethnic things also come into picture. The same thing what we heard may not be the same for a non-Indian. We don't know actually what is going to happen. Those are all research topics. I don't want to go there. But the Mattimavadi Raga was mapped to Shantarasa. That is a basic thing. That is what given over there. So this can be used for the key features. It is all reward focus. We can give reward points for the music, and then auditory training, the pitch training, the alankar or the pattern trainings, and then he can create his own alankars over there, and then get used up with the ragas. But then the 12 system can be converted to the 16 that is called as the in the Melakarta, there are two different types. In this, 12 and 16 are possible there with the same things, and also then the next complex Gamaka patterns using the 22 Shruta systems is also possible with this game.
Thank you, guys.
Thank you.